Hello everybody and welcome to Mr. Troy Does Math, a chill video series where I do math problems so you can see how I think. Today we are looking at graphs of rational functions. I want to find the following pieces of information: a horizontal asymptote, a vertical asymptote, x and y-intercepts, and a whole of the graph. So your first step when doing this is to factor the numerator and the denominator. So my numerator factors to x plus 2 times x plus 1. And my denominator factors to x plus 1. So I notice from that the x plus 1's cancel out. That means I have an x coordinate of -1 for a whole. You find the whole by looking at the 0 of the factor that cancels out. And then the y-coordinate you get by plugging that into what's left. So in this case, that would be 1. This isn't going to have a vertical asymptote because there's nothing left in my denominator. So no vertical asymptote. It's going to have a whole at -1, 1. To find the y-intercept, I'm going to plug in 0 for x, or I can just look at the ratio of the coefficients, so 2 over 1. So 0, 2. And the x-intercept is going to be the 0 of the numerator that's left over, so that would be -2. Now, the rules for horizontal and slant asymptotes. For this one, the numerator is a higher degree, so that is going to be no horizontal asymptote. It would actually be a slant asymptote, but Delta Math isn't asking me about that. So I think I've got all my information in. Let's see if I am right. Heyo! All right. All right, folks, next problem. Same setup. We're going to start by factoring the numerator and the denominator. And these are pretty easy factoring problems, x minus 2 times x minus 1. All right, so we've got some cancel action here. That tells me that we must have a whole in our graph. So when x equals 2, so 5 over x minus 1, except when x equals 2. If x were allowed to equal 2, we would get 5 over 2 minus 1, which is 5. So there's a whole there. We are not going to have an x-intercept. And the reason for that is there's no way to turn the numerator into 0. Our y-intercept, when we plug in 0, is going to be 0, 5 over -1, which is -5. Let's see, a vertical asymptote. Well, we still have this leftover factor of x minus 1, so x equals 1 is still going to be a 0 of the denominator. And then for our horizontal asymptote, it's probably easiest to look at the original problem. We have 5x over x squared. So since the denominator is a bigger degree, that's going to kind of reduce it down to y equals 0. All right, let's put all those in and make sure we're right. So y equals 0, x equals 1, no x-intercept, the y-intercept is 0, negative 5, and a hole at 2, 5. Now, hopefully I didn't get any of that wrong. I know if I got something wrong, you're screaming at the screen, Mr. Troy, no, 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 don't press submit, but here goes. Oh, phew. All right, so hope those problems were helpful. Hope that gives you a chance to look at a couple of those problems, and you can hopefully learn from that. All right, everybody, see you later.